Okay, good evening, Univara.
Good evening, sir.
Okay, let's start for the today's session. Today's session related to the PV pattern controlling to the battery. How it will control the battery, how to charge the battery, and after that how batteries work for the load system. Now to charging the battery, they will not can't connect directly to the battery. If you connect directly to the battery of solar panel, then it's not a surety of the maximum power transfer to the battery because of this. If you uh, you have a say solar panel, so do you want to connect a battery via capacitor to maintaining a voltage constant, the place of this one, a battery to charge a battery. If you're not connected to capacitor, there is no effect of the capacitor also. But to maintaining the output voltage, it is fixed. It is required the heavy capacitor or no capacitor. Sometimes battery also works like a capacitor. If you want to charge this one, then what happens? There is a voltage and current flowing through the battery also. The PV panel have a graph between Vt and It, and the maximum power is occurring at a point only. At a time, they'll find where is the maximum power. This is Pmax. It means if your battery voltage is this one and current is this one, that time you can get the maximum power from the solar panel. But it is not possible in practical cases. Battery voltage is same as the maximum power voltage of the solar panel. That's why there is no surety to operating a battery in a maximum power condition. So directly, if you want to charge a battery, in a practical, you can also consider this one as the source resistance and load resistance. There is no fix of the solar resistance is equal to the battery resistance. There is no surety of this. That's why there is no battery rating is different. Then how can you connect this one? If you want to get the maximum power from this to charge a battery, then there is a requirement of an converter, a DC-DC converter, which will place between the battery and solar panel. By this one, you can charge a battery via MPPT, a maximum power point tracking, by using a circuit algorithm which will track the maximum power. There is many basic converter. You know about the buck converter, boost converter, and buck boost converter. This is the basic converter. But in this scenario, there is a boost converter and buck converter is maximum used. Mm, Mostly a boost converter used, a buck converter. There is two boost converter used where you want to feed the power to the grid system, where you requirement of a high voltage. If you use a buck converter, then if you reduce the voltage, then after you feed the to the grid the higher voltage, then there's a problem. Then you use the simply boost converter to boost the voltage of MPPT of solar to a level of a DC voltage. After that, you can convert a DC to the AC and feed to the grid. Use a three-phase AC system. Whatever you want to a lower voltage like a battery is mainly in your home apparatus is the 12 volt and 24 volt, 48 volt. And the maximum common voltage is this one only. In industry there is a high voltage also there, but in home appliances there is a 48 that voltage. And if you take a solar panel or a 12 volt to charge the battery, 12 volt output voltage, maximum power voltage of solar to take this one, then the maximum is depending on the current rating of this one also. If suppose this one is the 12 volt to take to charge a battery, then you take a same charge by 12 volt like a 15 volt out supply. Then what is the current rating? If 12 volt higher rating is there, higher ampere rating is there, then the higher current is flowing through the battery from the solar, a requirement of full to full current. Then there is a possibility to exceed the buck converter or boost converter to another level, or would not be tracking because of the buck converter have some this restriction to work on the uh, 0 to 1 like that between them. That's why it will require to step down too much voltage of this one. At least zero point 0.5 duty cycle, zero point 6 duty cycle. There's a in practical cases 0.2 to 0.8 duty cycle is a nominal duty cycle. But you want to operate any converter in efficient manner, then it will be approximate of 5.5 volt like a 0.3 to 0.6 zero 0.7 maximum. Then you can take efficient voltage, efficient power from this one. And because you know about if you use a converter, something I give some practical things to you. Suppose you have a buck converter, have some switches, a capacitor and a resistor. Supply the circuits, diode, inductor, capacitor and resistor. Suppose you have a duty cycle like a 50%. Then what happened? 50% of inductor current is going to up and then down. IL. You can say this in the gate current, gate voltage to turn on this MOSFET. In this scenario, this switch is on for 50%. The same this diode is work for 50% only. Both are equal sharing, and you can choose as approximate value of this one to work like that. Some rating of power rating, and same thing if you can use just same current rating and power rating you can use here. But suppose you use for 0.8 per duty cycle, then what happens? This switches is on more time, then off time is very less in this scenario. Then at that moment this switch is on for very long time, this diode is work for very less amount of time. That time power loss are different for both. And one switches you can take it, one is a heat up, second was a not heat up, not it because of this one only. One switches is flowing to more power dissipation, and diode have a less power dissipation like that. Then you should choose switches like that to operating of this one. That's why it will be used maximum 0. If you nearly to 50%, if you use, then in practical cases they will get the most efficient converter. That's why voltage and current we choose like that to operate approximate 50%, like zero point 0.4 to zero point 0.6. It is efficient power. But buck converter have an issue in input side. You can say this one, if you switch it off, then the current will be totally zero. There is a huge, you can say, ripple current in source side in buck converter. That's why this is the another problem. That's why in maximum cases boost converter is used in this manner. But part of battery charge and buck converter is can use. Buck converter is very stable converter. Respect to the boost converter. If you learn about the buck boost converter, the boost converter have a right half zero, right half plane zero. It means there is a there is a non minimum phase is not there. There is a minimum phase there. Which one is a zero is placing on the right of half plane, which one make the overshoot comes to your system or the boost converter. And buck converter have a issue of a ripple current in input side. This is the carefully they should care of this one if you want to place the any converter. So, okay, let's start the question. Then after comes here. A boost converter is used to charge a battery in a current controlled manner. The boost converter is being supplied by 36 volt PV source. The battery has a nominal voltage of 60 volt. The boost converter uses a MOSFET power semiconductor switch, which is switched at 50 kHz. The boost converter uses a 4 millihenry inductor with a maximum current of 3 ampere. The slope in the current reference for a battery charger. Suppose there is a charger, there is a requirement of reference current. Why there is no requirement of voltage reference? In battery charger, mainly you know about the CC and CC board. I think you know about CC and CV. Is a constant current charging. This is the constant voltage charging. There are two modes to charge a battery: CC and CV. Constant current mode and a constant voltage mode. Is depending. In starting, if you want to charge a battery, there is a fully discharged battery. You want to charge the battery, then you want to the charge charge the very quick time. In that modern time, there is a lithium ion battery you can charge by I think 10C, approximately 2C, 5C also is there in the market. Very fast, 100 ampere current you can charge the battery suddenly. But there is state of time. State not standard. It will be a particular a voltage, a particular SOC. Till the SOC, you can charge the constant current. Then after you use the constant voltage device like that. Does someone have some question? Yeah, anyone has some doubts? You can ask. You can just say this was the SOC. Up to what percentage of SOC you can use the CC? Yeah, there is a 90%, 85 to 90% is there. In some cases, 80% also. It's quick charge at a CC mode. There is very high current flowing through the battery. It's charge quick charge. After that, what happened? There is an internal resistance. That's why you use the constant voltage drop. Because if you want to same current like V terminal voltage of this one is the VOC plus I B into RA, internal resistance of this one. If you use very high current, then this terminal voltage is showing like a full voltage. There is some voltage limitation in a battery. You can give us some example of this one. A lithium ion, suppose you have lithium ion battery, 48-volt battery. The maximum voltage is 58.6 volt and minimum voltage is upper voltage and lower voltage limit 40.5 something. Suppose okay for something. This is the voltage limit of the lithium ion battery. And suppose you charge this one, internal resistance of linear ion battery approximately 0.01 or 2 like that. To charge the 100 volt, sorry 100 ampere current rating. Then what is the terminal voltage of this one? VOC plus IB is 100 ampere and RA 0.02. Then 2 volt. It's showing a 2 volt extra if we charge a battery. It means if there is a 56.6 volt a VOC, actual VOC, then 2 volt is there, then it will be a 58.6 volt showing on our system. The system, what happens? System will sudden turn off the charging because of the it is exceed the voltage limit. After, because you can sense only terminal voltage of a battery, not a open circuit voltage. It will showing like 58.6 volt. It will be full charging of the battery, but there is not full charge because of the this voltage drop. Then what happened? It will be charged at 80% or 90%, 85% like that. It charge 85%. Then after it will be gives the constant voltage of 58, 59 volt. Then it will be charged slowly, charging the battery because of the current rating is very down. In that moment, then you can charge the battery. The voltage drop is very less at that moment. That's why it will use the constant voltage and constant current. If voltage is fixed, if a battery voltage is increasing, then current will be decreasing. Same thing. It will be 100%. So it will be approximate 85%. Sorry. This is used in modern time, that time. But it will be starting to charge the battery when discharge the battery is the older thing. If you want to I remove this one. Anyone have problem? I want to remove this one. So okay, leave it. There is a requirement of a current reference. How you set the current reference of a converter of a battery? Then you can track that current. Suppose there is a buck converter. Suppose there is a buck converter, a simple buck converter. There is requirement of a capacitor input of the buck converter. Why? Because of the switching. Input current, input and ripple current is very high in buck converter. That's why there is requirement of a bulky capacitor. If you not used up this capacitor, then there is a derating of your life cycle of PV panel and battery is more effective to the battery. Battery current is repulsed in input side at that time, then battery may get the affected of the lifetime of battery. That's why the requirement of the in buck converter. The terminal voltage VT switch will turn off and turn on from a duty cycle. Is a load or you can use a battery to charge the battery. Current of IV. Here you can connect a capacitor or you can disconnect a capacitor because of the battery also works like a capacitor, a bulky higher rating capacitor. If you get the data sheet of a battery, estimate a parameter of the battery, it will be like on resistance and RC circuit. Open circuit voltage is here or not, internal resistance R1 C1. This is the terminal voltage of a battery. The capacitor and voltage like that. Then you know about the value of this capacitor. If you estimate this parameter of a battery, it will be very high. If you estimate this one, a practical thing about battery, it is in 500 farad. Sometimes it's more than 500 farad. If you see in a laboratory, a capacitor like a 220 volt and 470 microfarad. Suppose 220 volt like that. There's a big capacitor, a 470 microfarad. If you use a bias 200 microfarad, 400 volt, this will be a higher voltage you use in our module buck converter also. This is a very high capacity in value and they are a big capacitor. Then what happen if you use the 500 farad? These are so bulky in a practical lesson, but the battery have this value of parameter of the capacitor. That's why there is no need of a capacitor also to charge the battery. You can neglect this one. Then how you provide the duty cycle? By giving some references. Suppose IL reference, some references there. After that you use the addition. Controlling of IL, you can control the battery IV current at the same time. So you can sense this one, this current feeding to here. Then after you can use a comparator circuit, which one compare to this one. This are connected to the ground. Then after you use a flip flop, SR flip flop, then output of this one is connected to the switches. This will be 0 volt. This will be a positive volt. Some comes from this one comparator. R is connected to the here, set is connected to the clock. In every clock there is active or reset the all thing. You know about SR, this was the SR flip flop simple. SR flip flop, you know about the truth table of this one. This is the state of this one. There is 0 0, both are 0, then there will no change in output. It will be same. State will be previous state. If set is 0 and reset is high, that means same thing. Reset the state. If set is high, reset is 0, then active the flip flop. If both are high, this will be no affected of this one on the output. Same thing, suppose there is a reference signal and IL. IL is a ripple current of inductor. Of inductor current which will be in ripple mode. There is a requirement some reference IL, reference current of this one. Suppose if you use the same thing, a constant reference signal, then this will be a this is a total time period TS. The clock is on, then it will be clock connected to the set is on period, then it will be reset. Once it will be on, then it will lose the controlling. Once on, then triggered and it will be working. Then it will be next state will be possible when reset or set is one was high. Suppose there is a one high, then what happens? There is a remaining time is there. Then it will possible when IL reference, the reference is tracking to more than the IL value. Suppose here IL reference is there and this will IL is more than this one. Then what happens? Negative is there. If a negative is there, then this will be more negative. More negative, it means less than 0. Then R will be 0. Okay. Suppose IL is uh, greater than the reference value. Then what happens? There is a negative value. If there is a negative value, then this value, a negative terminal value, is lower than the ground, or comparator negative value is lower than the ground value. Then what happen? A positive VCC is coming into picture. Then this will be a positive VCC. When we have positive VCC, it means R is high. When R is high, and then what happen? This will be a reset because of the clock. Once this clock is high, put the high signal, then this will be lose the control. Then after next page, next clock will be again high. Then reset the whole system. At that time, this will be gives the higher reset value. Then that time this will be high. Then output of this one will be 0. Then next station, next cycle, when the clock is next high, at that time against same phenomena. Clock is high, it means this will be a reference value. It will be this IL, if you want to track this one. If again it will be close to the IL reference, want more than the IL reference, this will be a negative value. Suppose this is a positive, then what happened? This will be positive, this is a positive. Positive is greater than the 0 because of the positive terminal connected to the ground. Ground, it means 0. This is some positive value. Then what happened? In output of this comparator is minus VCC because of the minus negative terminal is more to the positive terminal. And this will be a minus VCC is there. The minus VCC, it means this will be a 0. There is no change. Yeah, this one. Both are no change because of the already this one set value already 0, because once class is on, then this will be loose. Then both are 0 0, no change. Then next iteration, when this will be a more than the IL reference, this will be a negative value. Negative value, it means the negative terminal value is lower than the positive terminal value because the positive terminal value is 0. Then what happened? Positive VCC is on. It means this will be goes to high reset. It will be high, and this will be high. Then reset the output, and output will be 0. This is a phenomena what the duty cycle is 0 to high, like that. Because of this one only. This will be duty cycle, on duty cycle. This will be off duty cycle. When clock is on, then duty cycle on, and off when the IL reference is IL is a tracking going to beyond to the IL reference. But what happened if there is a very low current is flowing through it? The reference we should take a reference value from the function of the IL only. That time you can fix the reference value of IL. Because just suppose if you go to IL value like a fix a 10 ampere, then what happens? So 10 ampere is IL value is fixed. Then this will be not fully. If you want to track this one, it will be fully go. At that point, if the huge take a huge time to go to this one, then there is a problem to track this one. And what happened? You should give a function of IL to the reference value. Now you can give a function of a reference value. Suppose you give us some triangular value in place of this one. Suppose you can give a triangular reference of this one. And fix the maximum time, fix this one IL reference. If you track this one, then it will be a close to the 0. And IL start to tracking. If IL is same time, it will go to there, then it will be tracking exactly same. But if you, there is some disturbance, suddenly if you on this one, suddenly high current rating, this will be goes to here, then after it will go to down. Then you have to put this one a limit, goes to down here only, then it will be goes to high. And there, if a disturbance is there, then you can't be use directly as a triangular wave to this one. Triangular wave will provide some voltage current differences as well as the frequency differences also. You can't be give the fixed frequency of this one by the IL reference, triangular waveform. That's why on PW know about the uh, DC-DC DC-DC converter. There is a use of the sawtooth waveform in place of the triangular waveform in carrier wave. In all the carrier wave used to generate a PWM in any electrical circuit. To generate the PWM, you use the simple triangular wave or sawtooth wave. Triangular is wave used in all the system, but in DC converter it use the sawtooth waveform because of this is only. If a triangular wave if you used, then there is a, if any disturbance occurs in the circuit, then there is a differences occurs in your frequency also. Then how you fix the frequency? Because of the sawtooth wave. Then how generate the sawtooth wave form to track the IL? This one asking in the question also, what is the slope of this sawtooth wave form? There is a reference value, suppose IL reference you want to track. Then there is a slope, something slope like that. If you get this type of slope, then if you minus this one IL reference and this slope, then you will get the sawtooth waveform like that. This will fix the frequency and tracking also. You can generate this one from the this sawtooth waveform from your converter. Then you need this type of slope. This slope is coming from the converter, inductor current in off duty cycle. Suppose there is a buck converter. If there is a battery in output side, then the battery voltage is fixed, approximately fixed. Then what is inductor current? Inductor voltage, you know about this in off duty cycle. What happened in buck converter? Suppose there is a buck converter, in switch is off, then this diode will be forward bias. This will current flow like that. Like that, the inductor current, inductor is same thing connected to the across to the battery. It is same voltage. That means L di by dt, a voltage you can say this is voltage V minus a V naught, a VB. Someone is asking about the, if IL reference 10 ampere means uh, you are subtracting 10 ampere from sawtooth. Now difference between 10 ampere, then you slope. This one is the slope of the inductor current. Any slope is there, inductor current, if you minus of this one, then there you can get the this triangular waveform reference signal. This is the raw reference signal to track your inductor current in your converter. Then what happened this one, di by dt, minus Vp. If we integrate this one in off duty cycle, this is the slope VL by VB, battery voltage divided by F inductor. This is slope. If you consider slope of mod of this one, this will be Vp minus L. This slope is used here. If we integrate this one current, then what happening? Into comes multiplication of time. I, it will be minus Vb by L into I. Current dt, simply dt y1 minus dt is there in off duty cycle. Some quick can say some current, some times is there. This time is same thing. This time from here to here. Then this slope is taken to generate slope. Then after subtract the IL minus slope, you can get the sawtooth waveform, which one you want to implement in your converter. Actually, same thing. You can't be use this waveform to generate or duty cycle, because of something. If you want same reference given to the your converter generator PWM, it will be same. It will follow through this one. Then how can you track this one there? Here it will be 0 because of this one is the IL will be maximum to the your reference. It will same waveform file following through it. There is a disturbance is there. If you follow this one, it will goes to this one like that. Then after it goes to 0, then again goes to here high. It will follow a rectangular waveform like that. This is the IL. But you can't be use this type of waveform. That's why it will subtract from IL reference to this slope. Then you get this type of sawtooth waveform starting from 0. Starting from higher to 0. Then in this question is asking a boost converter is used to change a battery in a current controlled manner. The boost converter is being supplied by 36 volt PV source. The battery has a nominal voltage of 60 volt. The boost converter uses a MOSFET power semiconductor switches, which is switched at 50 kilohertz. The boost converter uses a 4 millihenry inductor with a maximum current of 3 ampere. The slope of the current reference expressed in a volt. It is asking about the slope to generate a reference signal. It is given a maximum current also. This is the I reference. Asking this slope, which is like that. Then if you subtract this one from this one, then you get this type of sawtooth waveform. Then what is this slope? Is asking in the question. Boost converter, it looks like that. The battery is there. Vs is given 36 volt and battery voltage is given 60 volt. Frequency is 50 kilohertz. Is very high frequency. Inductor is 4 millihenry. And IL maximum also given 3 ampere. Then we can set this one, the IL reference is the I maximum current of 3 ampere. Then know about our output voltage of this one is a Vs divided by F 1 minus D. Then what is the duty cycle of this one? V output minus of Vs divided by F V output 60 minus 36 divided by 60. This will 0.4 is the duty cycle. In off time, do you only calculate at the off time a slope. Off time slope, what happens? The switch is off, then this current is flowing through like that. Then what is the VL? VL is equal to Vs minus of Vb. You know about VL DIL by dt. And di by dt is Vs minus of Vb divided by F L. All value is given in the question. 36 volt minus of 60 volt divided by F4, it will be a minus of 6 volt per millihenry. But we want to slope of this one. Slope will be 6 volt per millihenry. Positive of this one. We taken only slope value. Not as, it will not consider the sign. Okay. What is the next question? A solar energy installation uses what is slope of current? Same thing, 6 volt per millihenry. Which is asking the question since slope. But di by dt is given minus 6 volt per millihenry. Then you can take from this one as a reference and take a magnitude of this one 6 volt per millihenry is the slope. If you want to in current and second, same thing. This will be a millihenry. Then you want to convert in Henry. Then what happen? Volt per Henry is same thing. Current per second. Ampere per second. You can find this one. If we multiply by this one at 10 to the power 3, this will be approximately 6,000 ampere per second. Yeah, it is possible. 6,000 ampere per second slope. Anyone can answer this one? Actual, if you want this one, this will not possible. This will be short circuited. 600 ampere is very high, but we uh, can't we operate BCC converter for a second. This is operation in microsecond only. If you use, just I want to give you, if you use a frequency of 50 kilohertz, then what is the time period of this one? 20 microsecond. If you use a suppose 50 maximum 50% duty cycle, then off time 50% of this one 10 microsecond only, not a second. You operate the this is the converter in off time only 10 second, 10 microsecond is very high. That's why there is a current in ripple current. So in a picture, yeah, scope, in the hardware, then there is a slope between 3 ampere, 4 ampere, 10 ampere only, not a 6,000 ampere per second. It will be per second is given. Per second, it means if you want that same thing for a second, then you can't be on this one because of the time constant of the inductor is L by R only. It will be saturated if you go beyond to this one. it will be a saturated, it will not operated, and can't be do the operation of buck converter and boost converter. A solar energy installation uses three-phase line commutated a full bridge converter to feed energy into power system through a transformer of 400 to 400 isolation transformer. There is a collected PV array in a bank of 400 battery and connected to through a converter. A large filter choke is there, which resistance is 10 ohm. No, what is the maximum current through the battery will be? Sorry. What is the maximum current through the battery? You know, maximum current is flowing when the this voltage will be zero. Battery is flowing through current like that because there is just some solar. Eh, Yeah, I think 40 ampere. Just some solar. You will charge the battery sometime. After that, this battery is delivered to the grid, connect to the grid. That's why the current is flowing through the this will be the zero. And what happened? 400 minus 0, IB maximum. Never we have this current, this resistance. So 40 ampere only. That a solar energy installation uses a three-phase line commutated. Will be same question, I think. Brand battery, this converter connected through the battery filling the 10 ohm. Then what is the kVA rating of transformer? You know about the kVA rating? kVA rating of any transformer is the in a three-phase transformer. Root 3 VL IL in RMS, not a peak average. This be also RMS. Line voltage RMS is if this rating is given anywhere, transformer rating like 400, 400 is given, that it means a three phase RMS value, line RMS value. It is also always mentioned standard thing because I was given is three phase. If there is a single phase, then not it's the same thing, single phase RMS voltage. C, okay, root 3 VL IL. Root 3, okay, VL is given 400 volt. What is the current IL in RMS? Current in RMS, this one is the input side. This is a three phase converter. Sorry, three phase bridge converter is there. Then how calculate the RMS line current? A three phase inverter, no, it will operate it for the 120 degree and off for same thing. And after another 120 is operated another phase. Then you need only a line current. Line current is a single, you can say a single line current. It will operate it on 120 degree only. It will be off for 60 degree. After that, it will again on. A line is on for 120 degree and off for 60 degree. Total time period is T 180 degree. For a single current, suppose it's a 60-60 block on for 120 degree, then off Another signal is on for 120 degree, then off. Another is on for 120 degree, then off for 60 degree. We are operating like that. For a three phase bridge rectifier, if you see this one, same thing. Then what happened? On part 120, now if you want to calculate the RMS of this one, yeah, any signal, suppose I will remove the all thing. If you want to calculate the RMS of this one, now calculate this one. Simple. If you have an square wave, any square wave, you have this one. Simply, if you want to calculate IRMS root of this one, same thing, square of this value, sorry, into on time. On time is there for 120 degree divided by your off time. Off time is 180 degree. Then what happened? IRMS, ILRMS, same thing. IL peak का जो भी into root 2 by 3. This is the RMS value of a line current, which is input side of a converter, a bridge converter. Any square wave you can calculate RMS value like that only. Same thing, IL square divided by 1, which is the value, into on time divided by your total time. If there is on for 60 degree, then same thing, 60 divided by 180. Simple thing. If there is a 50, then 50 50 will be 50, and 150 there is a root of this one. If you want to pure square wave form, you want to calculate RMS value on for 50, off for 50 degree, then this will be simply IL divided by root 2, because of this one only. This will be 50, this will be 100. Do okay. Then calculate this one. IL RMS. IL is 40 ampere calculated in previous case, divided by 2 by 3. 40 into root 3, root 2 by 3, it is 0.813, I think. This will be a 32.65 ampere. Then kVA rating, root 3 to voltage VL 400, IL 32.65, 22.6 kVA. The kVA rating of this one. Okay. Another question is, the following circuitry can be used in battery charge controller to reduce the chattering and proper operation of a mechanical relay used for switching. Simple on-off circuit. Which of the following will be a correct transfer function? Transfer characteristic of the circuit. Okay. Transfer characteristic is given. This is the two op-amp connected. One connected is the negative feedback, another in positive feedback. If you know about the Smith trigger, Then this circuit is same thing, Smith trigger. Smith trigger have some saturation limit which one operating between them. Okay, I just explain first Smith trigger operating, then after this one. Suppose there is a sub voltage Vs, so variable voltage, not a fixed voltage. The output voltage VCC. You can say this one minus VCC or plus VCC, anything you can say. If you take this one minus VCC, this one plus VCC. This one will be negative, this one positive, anything you can take. Just for reference only. This voltage is the reference voltage. You know about the op-amp input impedance is very high. Is the if there is a note not mentioned in the question, simply take as the infinity input impedance of a op-amp operational amplifier. Then what happens? There is a zero current flowing through it. In the op-amp, there is a zero current flowing through it. Then how it will operate? It will operate per plus VCC minus VCC only the voltage measurement only. Same thing, voltage measurement from positive to negative terminal. It will be operated. If a positive terminal is high, then output is the plus VCC. If a negative terminal is high, then output is the minus VCC. A simple case. It will compare between them. Now the voltmeter have impedance is very high. Same thing here. Because of same compared to two signal there and voltmeter. It, input side is same like a voltmeter and output side is like a voltage source. This is low impedance both output of the amplifier. Okay, leave it. Then you can say this is the if a zero current flowing through it, then what is the current of this one? Current flowing directly like that. This is the simply a voltage divider. This is the output voltage. This is the ground, and this is the V reference. R1, R2. Then what is the V reference voltage? So the series connected resistance. We can use a voltage divider. Output voltage into R2 divided by R1 plus R2. You can calculate the V reference value. Output voltage is plus minus of VCC only. You have to decide when it will be plus VCC and when will be minus VCC. Simple thing, if Vs, this supply voltage is greater than the V reference voltage, then what will happen? Output voltage, this terminal is more negative, negative terminal is high, negative terminal is high, it means minus VCC comes to the output. Same thing, if Vs is less than the minus V reference, then output will be a plus VCC. It means the same voltage is negative, then more than negative of a V reference, because of the this is the 50, this is the negative value, more than the negative voltage of this one, then it will be a this will be a high. That time this will be a high voltage to this one, then positive VCC is coming to the output. Then Smith trigger have some saturation limit. This is the output and this is the input voltage. Saturation output voltage is varies from plus VCC to minus of VCC. Saturation limit is depending the reference value. We compare from the source. Then reference value is here plus V reference will be a minus of V reference. Circuit is given if Vs is greater than V reference value. It means Vs, same thing Vs, this will be Vs, is greater than V reference, then voltage will be negative. It means the between them it will be a plus VCC. When it will be reached to this one, this will be a negative VCC. It will commence like that. Same thing negative side, Vs is more negative to the V reference. Then this situation the output voltage is plus VCC. It will be like that. This is the Schmidt trigger output voltage characteristic versus input voltage. This limit is shown as the saturation limit of this one. This one VCC to minus VCC, and this is the knee point or reference point plus B reference and minus BC reference. In your question is given a circuit of this one is Schmidt trigger, but the input is not directly a Vs supply voltage. Here is some circuit to use to given to the voltage. Then first calculate this voltage Vs. Then after you can use Schmidt trigger. Okay. If there is some voltage applied from here to here, some is negative, some is positive, if you confuse there, and simply used a voltage, take a voltage VA, VB, and you know about VA, difference between them is VN. This type of circuit is there, then simply use the VA and VB. This current is flowing through it is zero because of high impedance rating. If a negative feedback is there, then you can say this will be a virtual short of this one. This voltage will be same if there is a negative feedback, but here is the positive feedback. That's why it's known as the Schmidt trigger. If same thing in negative feedback, then you can take as same thing, both are virtual short. This is a negative feedback, then you can take this will be virtual short. This voltage same as this voltage. Then what is this voltage? VB connected to the this two resistance connected in series because of this current flowing through it is 0. Then this voltage will be VB by 2 only, half of this one because of same resistance. If this voltage is V by 2, then this voltage is also VB by 2. Then if you compare the current flowing through it 0, then same current is flowing through here also. Then VA minus of VB divided by 2. This voltage divided by resistance. Voltage difference between resistance is the same as this voltage minus of Vs. VB by 2 minus of Vs. This voltage divided by this resistance. RR will be cancelled out. Then what happened? VA minus of VB by 2 minus of VB by 2. If you transfer to the left hand side is equal to minus of Vs. Then this will be VA minus of VB is equal to minus of Vs. Then this will be a V in is equal to minus of Vs. We can say Vs is equal to minus of V in. Okay. Then solve this circuit and find the reference voltage and VCC. And how we will solve this? This is the Vs coming from the another. This is the minus VCC. This is the upper plus VCC. VCC in the question given as 12 volt. Then what is the V reference? We calculated V reference is V output. This will be R only. So half of this one V reference V output into R divided by F R plus R. It will be 12 by 2 6 volt. It means if Vs is greater than the V reference, then output voltage is equal to minus VCC. It will be a minus of 12 volt. If Vs is less than of minus V reference, then output voltage is plus VCC and it will be a plus of 12 volt. But Vs is same as the minus of V in. Minus of V in, suppose multiply of this one to negative, then what happen? Suppose there is a minus, suppose some value is there, 5 of some value like minus 6, suppose minus 5 is greater than the minus 6. If you want to multiply m negative of this one, then what happen? This will be positive 5, this is positive 6. Then at this time we should also change the direction of this one. 5, it will be a less than the 6. Same thing here. If you multiply of this one, then V in will less than the V minus of reference, then V output will be minus 12 volt. Same thing here. Vs is minus of V in less than a V in reference is given, then output voltage is given 12 volt. Then same multiply by negative here, then V in will be greater than the V reference, then output voltage will be plus 12 volt. Take these two, V in less than of V minus of reference, then output voltage is minus of 12 volt. If V in is greater than the V reference, then output voltage is 12 volt. A reference V reference, you know, this will be a 6 volt only. Then take a VCC plus VCC, which will be 12 volt. Output voltage is there. V input voltage. This will be a minus VCC, which will be equal to minus of 12 volt. A reference set reference is minus 6 volt to plus 6 volt. If V in is negative to the minus V reference, then output voltage is minus of 12 volt. It means this will be like that. Then will be triggered. Triggered will be when the V in is greater than the V reference. It means here. It will triggered here only. This will passing through here. Here only. Then it will be triggered. That's why it's known as the Schmidt trigger. Triggered here. Then current flow like that. If you take another one, this one, if V in is greater than V reference, then it will be same thing. If it comes from a higher to lower voltage, then what happens? It will be comes to have when it will be a minus negative, below the minus of V reference. That time it will be a negative VCC. This is the Schmidt trigger, which one output voltage comes from in a saturation loop forming by the Schmidt trigger. It will trigger the voltage when we exceed the reference value plus VCC to minus VCC. And this is the answer of the question. Schmidt trigger is there, then that's why this will be not possible. This will be when the negative voltage is not applied. When the negative op-amp is not there, then this answer is correct. But here the negative of Vs is equal to a minus of V. That's why this is correct. Yeah. Sorry. Next is given the question: the following circuit is used for a mathematical operation in a battery charge circulation operation. Which of the following operation is being implemented using this circuitry? It was asking about the output voltage. C. Yeah, someone given is C. Let's solve this one. V1, V2 is given. Suppose this will be V01, this will be V02. The output voltage. This is a negative feedback. Then what happens? This voltage is same as this voltage because of virtual short. Same thing here is a negative reference, negative feedback. And this voltage same thing. This voltage. And there is a current flowing through it like that only. It will not go into the inside the op-amp. And this current is flowing. It will here to here like that. It is flowing anywhere there. Can take a reference. Okay. First calculate this current. This current will be a V2. Sorry. Then V2 minus of V1 divided by F2R is equal to V1 minus of V0. Yeah, if you want to take the same current flowing through it like that, then this will be V1 minus of V0 divided by R. R will be cancelled out. V2 minus of V1 is equal to 2V1 minus of 2V0, or you can say this will be half of this one, V1 minus V0 1. Same thing if you apply here, then V2 minus V1 divided by F2 over is equal to current flowing here V0 V02 minus of V2 divided by R. This voltage same thing, you can say V1 minus V01 is equal to V02 minus V2. And V1 plus a V2 is equal to, you can say V01 plus a V02. Here. Then what about this circuit? Suppose take some equation voltage here VA. Same thing because of the negative feedback. This is also VA virtual short. This current is same flowing through this current. This one current is flowing through this one also. Then V02 minus of VA divided by of R is equal to VA minus of V0 divided by of R. It will be same as V02 is equal to 2VA minus of V0. Same thing we have taken this one, this voltage minus this voltage, V01 minus of VA divided by of R is equal to VA divided by of R. Then V01 is equal to 2VA. V01 minus of V02 this one you can find the this one is V0. Oh, there is some problem. V01 minus of V02 is equal to minus V0 and V1 plus V2. I think there is some mistake. Maybe add this one, then what happened? 2 V naught 1 is equal to V1 plus V2. The value here, find the V naught 2. There is no problem. Just positive negative is mental here. Okay, we can apply KVL. I remove all the thing. Just apply a KVL between here, this loop. Take a current anywhere. If this one is the VA, this is also VA. What is the current flowing through it? If you're taking this one is the V naught minus a VA divided by your resistance, this one. This current is same as this current. If you're taking this current like that, making a closed circuit, then this current is what? VA by R going through it because of the resistance. Then same voltage drop is what happened, this one voltage VA. And apply KVL here. And this current is this current V2 minus V1 divided by F. V2 minus of V1 divided by F 2R. This current flowing through here. This is the same current. Then just apply KVL here and find what is this. This voltage drop is V naught minus of VA divided by of R into this voltage, this current, then this resistance is R plus this resistance, current is flowing V2 minus of V1 divided by of 2R into resistance R plus this voltage drop V2 minus of V1, same voltage drop will have a current by 2R into multiplication of 2R plus this voltage drop V2 minus of V1, same current flowing through it because of the no current flowing through it, G here 0 into R plus this voltage drop plus V is equal to 0. Then RR will be cancelled out everywhere. This will be a V naught minus of VA plus V2 minus V1 divided by F2 plus V2 minus of V1, 2 are cancelled out, plus V2 minus of V1 divided by F2, RR will cancel out, plus VA is equal to 0. In what pattern? VA will be cancelled out, V naught plus the V2 minus V1 divided by 2, V2 minus V1 divided by 2 is 1 V, same thing, plus is 2 V2 minus V1 is equal to 0. Then output will be minus of 2 V2 minus V1. If negative is there, you can reverse this one, 2 V1 minus of V2. Same thing. Yeah, this one. C option is correct. Okay. Next question given of 5 batteries, each of 12 volt nominal are connected in series. Of 5 battery connected in series. A charge pump based equalization circuit is employed. The reservoir capacitor voltage can be. If there is a two battery, if you want to equalize them. If you have two series connected battery, if you want to connect two battery in a series, then it will not be possible to both the battery have a same characteristic. It's showing to same characteristic from full load to fully discharged to fully charged. There are some differences in voltage and SOCs because of the manufacturing error, environmental error, the material error, then a lot of things. Then it will be not performing the same at the same moment. Then it should they want to equalize them between two. Then you can use simply a series resistance, shunt resistance to discharge the overrate over this one over SOC. And another thing, you can transfer from energy from higher battery to the lower battery, or you can transfer energy from higher battery to the peak of the battery, or you can directly charge from peak to directly to the lower battery. Peak it means this one, whole combination of this one. Charge pump equalization, it means the inductor and capacitor is there. The switches is here and inductor connected to the every battery. There are capacitor with capacitor to connected. We are like that. And what happened? You can see this one the V1, V2. This one is the high. The switch is on, the inductor will be charged. Then switch is off, the inductor will be discharged through this capacitor. Then after there is a used to transfer this capacitor energy to the pack by using some circuit like that. Then same thing, this circuit is used like a boost converter. This one. That's why this capacitor will be a below to the you can use below to the rated battery voltage spike. If this battery voltage spike is suppose V1, then this capacitor because of this is used, then you can same as or lower to this one. Same as you can use the pack voltage, capacitor voltage. The- Lower of this is a 12 volt nominal voltage of 5 connected to the battery, then B pack. Sorry, B pack of this one is B 60 volt. This will be charged like that. Because the current is flowing to charge the capacitor like that, then it will be a positive, negative. This will discharge through the inductor. Then if switch is off, then this inductor transfer the energy to the here, like a boost converter. Then this capacitor voltage should be lower than the spike voltage. The VPAC. VPAC is 60 volt, then lower of this one you can use the boost converter to boost the voltage from lower voltage to the higher voltage. Because this voltage is only one voltage, V1, voltage applied to the capacitor, and this voltage transferred to the pipe from this inductor, like to boost this voltage. That's why they use the lower of this one, lower of 60 voltage, 48 volt, then you can use. A lead acid battery and lithium on battery are supposed to supply current to a common load. Then they should connect any battery in series. No, because of the chemical, the equivalent is very different between them. Lead acid battery and lithium battery. If you charge this one, the one battery is fully charged, and the second one is the very less, and the discharging time one is the suddenly discharged, and another is not fully discharged. Then there is a problem in series connection. Series connected between the battery is approximately similar battery you can say connect in series. That's why you can't be connect in series. They should be connect in parallel. You can send the collect in parallel to transfer the load, to share the load from both. They should not connect in different type. Should not use batteries of different type. Now you can use, but in parallel combination. Should you use a charge equalization? Yeah, you can use a charge equalization. Any one you can select. This one is the parallel combination. Charge equalization is not required in parallel combination. That's why as different type of battery you can use in parallel combination. That's why it is not correct. This will be correct. A 20 Ah battery with a nominal voltage of 12 volt is connected to the terminal of PV module for a charging. The PV modules has a short circuit current of 2.5 ampere, open circuit voltage and VOC is given 14.5 volt. ISC is given 2.5 ampere. And the battery has a C rate of C10. Rate of C10, it means it will take 10 hour to discharge a battery of a capacity. Any battery take a 10 hour to discharge. C10 means that. If the internal resistance of battery is 0.5 ohm and appropriate operating point, to charge the battery of a 12 volt battery, C rating is Given a 20 Ah battery, C rating is 10 given, then what is the current? 20 Ah divided by F 10 hour if you want to current, this will be 2 ampere. Then you have requirement of 12 volt and 2 ampere. Then it should be more than this one. You can take operating limit of this one. Yeah, 2.5 ampere is there, is okay. But in short circuit condition, you can be use same thing. Short circuit current, it can be flow. If you want to make a maximum current, but this will be 2.5 ampere. 2.5 ampere you can't be used 2.5 because of the C rating is 2 ampere only. That's why you use the 13 volt 2 ampere, the operating point of this one. Same question, 28 by T, nominal voltage C10. Eventual resistance 0.5 ohm, then the approximate input resistance seen by the PV module across the terminal. Same thing Vt by It, the input resistance, Vt is given 30 volt, It is 2 ampere, then 6.5 ohm. It is showing from the input outside of PV panel or input side of converter. A duty cycle ratio of DC converter shown in the figure is 0.4. Assume the inductor current waveform to be continuous. The charging current of 5 volt battery under the stated condition. Yeah, you want to calculate the charging current of this one, this current. IB same as the I naught, and I naught, then then find this voltage, whole voltage V naught. Then you can calculate the IB. How you calculate IB is equal to V naught minus of 5 volt divided by of 3 ohm. First calculate the IR. This is a buck converter. Yeah, this is switch is on. Simple buck converter. Then output voltage you know about dVs. Duty cycle 0.4 is given and 12 volt. Then what is the output voltage is 8 volt. Oh, this is simple. You can calculate IB 8 minus 5 divided by F3. So there will be a 1 ampere of current flowing through battery. A photovoltaic model has been open circuit voltage of 16 volt and short circuit current of 3 ampere. Same 16 volt short circuit current of 3 ampere. This MIP model is directly connected to a battery which has a no load voltage of 12 volt. The battery is getting charge from the PV module then the most appropriate point. This is not mentioning about the C rate and capacity of this one. Then most appropriate point you should use this will be the no load voltage of the battery 12 volt. For charging the battery of 12 volt battery you can't be use same thing 12 volt power supply or lower the 12 volt. You should use the more than the 12 volt supply. But ISC is 3 ampere. That means the approximate 90% of this one, 90% of this one is MPPT you get this one. Then approximate to the 3 ampere current you used. Then this is the appropriate operating point 13.45 volt is more than the 12 volt and 2.7 ampere current which is lower than the ISC and approximately the maximum power point. That's why you can choose the operating voltage 3.5 volt and 2.7 ampere for this battery. Same thing, same with a reference of same thing question internal resistance of the battery. Internal resistance, we know VO, solar panel VT is taken as 13.5 volt, current IT 2.7 ampere, and VB is given 12 volt. The internal resistance circuit looks like that, directly connected to the system. This VT is given, this is IT, same as the IB, internal resistance R naught, VB. VT is equal to VB plus IB into RB, R naught. VT is given 30.5, VB 12 volt, IB 2.7. Just calculate R naught. 30.5 minus of 12 volt divided by 2.7. 0.55 ampere. Oh, sorry, ohm. Resistance is asking. A photovoltaic module has an open circuit voltage of 16 volt and short circuit current of 3 amperes. Same, I think. Both the PV model and battery are supplying power to a load of resistance of 1.64 ohm. It means it looks like a PV panel. And there is a battery. Both are connected to a load resistance of 1.64 ohm across the terminal of the PV module. Then the approximate operating point is, then VB is equal to voltage given 12 volt. Then first calculate the load requirement of this one. I L 12 divided by F 1.64. Seven point three ampere. If there is a 12 volt and operating supply the current 7.3 volt, then definitely this will be a charging from the panel. It should be greater than the 12 volt of VT. Then appropriate point is given maximum is at 3 ampere. Then it can choose the 14 ampere, 14.5 volt and 1 ampere is there. That is very low. Then we should check this one. Operating point is voltage 30.5 volt and 2.7 of ampere. The approximate of nearer to the short circuit current. Remaining power is delivered by the battery. It's like that. Sorry. A buck converter is used to charge a battery in a current controlled manner. The buck converter is being supplied by the PV source. The battery has an nominal voltage of 12 volt. The buck converter uses a MOSFET power semiconductor switch which is switched at 50 kHz. The buck converter uses a 4 millihenry inductor with a maximum current of 3 ampere. The slope of the current reference should be know about buck converter? Simple. I just draw a sketch diagram. Switches is there, a diode is there, a capacitor, and this is voltage of VT, IL current, IV. This is the VB. For the slope will be triggered at the off time. The switch is off, then this current is flowing through inductor current like that. Taking this as the VL, and what is the VL? The same as the minus of VB. And L inductor current di by dt. L di by dt is minus of VB. Then di by dt is equal to minus of VB divided by of L. Voltage given 12 volt. For the slope 12 volt divided by of L 4 millihenry minus 3. Twelve volt, I think, not 20 volt. Minus 30 into 10 to the power 3, it will be minus of, not 33, 3000. dA by dt is equal to minus of 3000 ampere per second. But it mentions slope in the current. Reference. The reference, what is it? It will not consider the negative terminal. In the reference, it will be a positive 3000 ampere per second. Slope will be 3000 ampere per second. Do not take any the negative as a reference. The next question, consider an application where 4 batteries of 12 volt each are connected in series to achieve a 48 volt DC bus. If the resistive charge equalization circuit is employed, then what is the loss of the charge equalization circuit if 1 key resistance is applied across each battery? This is a 4 battery connected in series, then resistance of 1 ohm connected across each battery. To equalize this one. All of 12 volt. You know about the lithium ion battery? A lithium ion battery is formed to stack of a cell, number of cells connected series and parallel. A cell voltage rating is nominal rating of 3.7 volt only. A range is 2.5 to 4.2 volt. If you want to make 48 volt battery, then you should connect up 14 cells in series like that. You want to dot 14 cell to make a battery. Then there is a requirement of the cell balancing needed. You can't be charge any cell beyond the 4.2 volt, or you can't be discharge any cell to below the 2.5 volt. And there is an electronic circuit which is known as the VMS circuit. It will be cut off the all circuit, cut off the load and charger when it will just exceed this one. Like if you exceed 4.2 volt, then it will cut off the charging controller. Even if any of the cell is not charged fully charged because of the characteristic. But if any cell is crossing the 4.2 volt, any cell of a whole 14 cells, if any cell crossing the 4.2 volt, then it will be cut off this power supply. Just can't be charged more than 4.2 any volt. Then there is a requirement of a cell balancing. And there is a two types of cell balancing, active and passive. Then same thing, same phenomena is using in a cell balancing of a passive balancing, which means which one is a higher capacity with already discharged through a resistor. If any battery is more charges, then it will be charged. Question number one is a boost converter. Here is the buck converter in 14 questions. Just to realize the converter. That's why there is differences. Then what is the power loss of this one? Power loss of each resistance. If the same battery is there, then same power loss for the 4 battery. Into V square by R only 12 square into resistance of 1K 4 into 144 divided by 1000 0.57 watt power losses. Okay, thank you to all. If you have any doubt, you can ask. Okay. I will take this question.